Hello and welcome to Book Bites, a book club podcast for developers. This time we're talking about 7 languages in 7 weeks. The language we're talking about today is I-O. I'm excited about this. This is a weird language.
All right. So it definitely it is a weird language. It's a language that I kind of wanted to look at from the perspective of other languages, partially from like the Ruby perspective, where it was really flexible, but then also thinking of either Lua or JavaScript-esque type perspective, because it is prototypal. And
okay, so Lua is another prototypal language?
Yes.
Okay, I dabbled in that, but I did not know that.
Mm-hmm. Yeah, Lua is very similar in that at its core, it has tables as the one root thing to rule them all. I won't get too far off onto Lua, and unfortunately they don't have it specifically in this book, but there are some similarities on that front.
Yeah.
But
do you have any follow-ups from last week about Ruby?
So my only follow-up is that I did do some comparison with I/O and Ruby related to like performance type stuff. Nothing major, but
okay.
Yeah.
Okay, so maybe we'll get to that later.
Yeah, I'll mention that in just a little bit.
All right, so Ruby compared to Mary Poppins because she's a good nanny, she's magical, and she kind of improves the people around her. And then I/O is compared to Ferris Bueller from Ferris Bueller's Day Off, where he, if you like to party, he'll show you around the town, he'll try anything once, might
cut in class.
Yeah, might give you the ride of your life, might wreck your dad's car, might do both. You're definitely not going to be bored, and there's not very many rules to hold you back.
Yeah, I think that is a pretty solid analogy of being able to go and bend the rules or completely break them if necessary. I/O gives you a lot of extension points in order to do that.
And it's said that Ruby gives you a sharp scalpel, like a rope to hang yourself with, so you can really mess things up. I feel like I/O is probably the same way. What do you think?
Yeah, you can definitely mess things up, given that you can go and take some of the core elements, like the I guess at its root being object, because everything within I/O is an object. And if you want to make something that inherits from object, you use object and you give it the message of clone. But if you happen to go and overwrite the clone slot on object, then you can no longer create new things. And so, yeah, you can definitely work yourself into a really bad corner with it if you do something wrong.
Yeah. So one of the things I liked from the introduction here is that if you learn I/O, I think even a little bit, dip your toe into it like we did, it will help you understand how JavaScript works better.
Yeah, and I definitely see that, in that it doesn't go and hide itself behind new calls that JavaScript has, and instead everything is just cloning from some other prototype the whole way up.
Yeah, and it doesn't hide behind a lot of fancy syntax either. There is no syntactic sugar.
No, it's and with that, it actually changed my perspective on what was going on, or at least my thinking process, particularly with objects and anything that inherits from it. They have slots similar to, properties on JavaScript objects, but one difference is when you're actually calling those slots or sending messages to them, you don't use a dot. And that was one thing that I feel like I tripped up on a number of times, where it would be like car.start or something,
right,
is what I would wind up typing when in fact it just needs to be car space start. And I almost feel like the not having the dot there removes the idea that you're calling something on car, but instead you are actually sending the message of start to the car.
Right. Yeah. There's
And
a good separation between the object and the message. And you could try to send that message to any object you wanted to and see if it can respond to it or not.
Yeah.
And then if
Yeah,
you try, it'll just say this object can't respond to this message or something like that. Yeah. Object does not respond to and then it would say the name of the message.
Right. And it definitely aligns with kind of what Alan Kay, creator of Smalltalk, was thinking of when he kind of termed object-oriented programming. He actually went and on Stack Overflow explained that he should have actually called it message-oriented programming rather than object-oriented, because objects are not the major part, but in fact the sending of messages is what he always had in mind with it. And in IO, messages are huge. Like it said in the book that almost everything is a message that you can send from one thing to something else. And then if that object chooses to respond to it, then it can. Otherwise, it just keeps going up the chain.
Yeah, so it will look at its parents' prototype to see if it can respond to that message, or its parents' prototype, or its parents, until it gets all the way to object.
Yeah.
And also, what I thought was really interesting is that types, each object has a type, but it's just a slot. So objects have slots, and type is just one of those slots, and it tells you the name of the type, right?
Mm-hmm.
And
yeah.
If you clone a new object, but you actually name that object lowercase, then it doesn't have a type and it will use its parent's type instead.
Yep.
Naming it lowercase is like a convention, but it's a convention within the language because it means when you clone this, don't add the type. And then because of prototypal inheritance, it will get its parents.
Have you seen other languages that have semantics like that?
No, have you?
The one that I can think of is Go.
Okay.
Which it's not exactly like that, but if you go and name something within a Go module with a lowercase letter, I believe that it doesn't get exposed. I would have to go and double check on that, but I know that it actually cares about like what you start stuff with. But kind of small conventions like that to enforce a behavior or give you a benefit for taking a specific approach.
Yeah.
So tell me about your day one, Adam.
Day one. All right. Are you talking about the problems in day one or just learning day?
Whatever you did on day one. Yeah. Like what did you have as a takeaway?
Well, I mean, it says methods are objects. So really everything is objects. I have a question about that though.
Yeah.
Are messages objects as well?
Yes.
Okay. Everything's object.
So yeah. So messages inherit from object.
I love the little list of bullet points that explains the prototype programming paradigm, at least in IO. And I might as well just read it off. For the listener, it might clear a few things up. I don't know.
Sure.
Everything is an object. Every interaction with an object is a message. You don't instantiate classes, you clone other objects called prototypes. Objects remember their prototypes. Objects have slots. Slots contain objects, including method objects. A message returns the value in a slot or invokes the method in a slot. That one may be a little confusing, but message returns the value in a slot. And then if an object can't respond to a message, it sends that message to its prototype. Yeah.
Rinse and repeat. Yeah.
Yeah. So what else? I finally learned what a singleton is.
Okay. Well, then here's your test. What is a singleton, Adam?
In my understanding, a singleton is always the same thing. So, for instance, if you try to clone it, it always returns the same object every time. And then they would different clones of that singleton would be referentially equal, like the same pointer to the same object.
Correct.
Okay.
Yeah, and I mean with IO, because it lets you go and redefine what the clone slot is for a particular object, you can actually do that. Whereas in other languages with new and ones that can like invoke a constructor, like you can't actually go and return the same object. Like new itself forces an allocation of something
Uh,
new, and instead you wind up having to go and have some like static method on a class or something to say like build or get or
yeah. So it's cool. It's cool that that's built in. That's built into IO, and true and false are examples of singletons.
yeah. I actually learned some kind of fun behavior about even true and false. So my first exercise that I opted to do, it wasn't actually listed in the book because it may have even been before it was a thing, but I went and decided to do FizzBuzz because if I could do that, then I'm a real IO programmer.
Right.
So I went and wrote it, and I learned that the if method that exists on object, and when you're calling kind of at the top level, you are sending messages to the object. And so like using if, there's kind of two ways of calling it. I think in the book it calls out the way of passing it 3 arguments.
Yeah.
Where if you get the first one being some conditional that is truthy or falsy, and then the true case and the false case. And you can also, though, invoke if with just a single argument. Yeah. And if you do that, then it will actually coerce whatever it is into either true or false.
Okay.
Which actually answers like the first exercise. But I didn't quite realize it at first. But after you do that, true and false both have slots for then. So they are objects that can receive the then message. And if false receives then, all you get back is the value of false again. Like it returns itself because you don't actually care about what's inside of the message. And true, on the other hand, actually evaluates it and then it returns nil.
Wow.
So and then like the flip happens for false and else. And then also nil has an else slot on it too that returns nil. And so like I mean, I have a little table of them that I put together listed in my notes, but what that allows you to do is say like send the message of if something, and then to whatever comes out of that you can say then something, and whatever comes out of that you can say else or else if, and have those as all separate messages that are getting sent to those individual true, false, or nil combinations.
And so you were saying true and false have slots on them for else and then?
Correct.
Okay. That's really weird. So it was also cool that in IO you can send the message slot names to any object to see what slots it has.
Mm-hmm.
I don't know if there's a way to see, you can see the names of those slots. I don't know if you can kind of see the implementation of them.
So if you want to see the implementation, you can use get slot, and then so send it the message of get slot with the string of whatever slot name you're looking for, and then and that will go and give you back whatever is actually in that slot.
That's really cool.
Or I guess the implementation of that slot, I should say. So it won't invoke it. And for native ones, it will just like it will often be like object underscore whatever, like object underscore if, because I think object if is one. But if you've implemented it within IO, then you should actually be able to see the source of it, like of the method.
That's another thing about IO. It was very easy to install.
What did you do?
I just went to iolanguage.com, hit download, and ran an installation. How'd you do it?
Brew.
Okay, I should have done that. But either way, really easy.
Yeah. Well, actually, I installed it with Brew and it worked, but it was a version that was not in line with like their master version, and so it actually gave me a chance to score some Hacktoberfest points, and I went and updated the Brew formula so it builds head correctly.
Okay.
So you can get the head release. So if you do brew install -- head IO, then it'll get you the Master Ranch version of it that has some new stuff in it. Like they have a package manager now.
Oh, really? I had no idea.
Yes. Yeah, there's a package manager called Erie.
Erie.
And I don't quite know the reasoning behind.
Yeah, I mean, I don't really know
Erie,
the reason behind the name of the language. I just know it's always capital I, lowercase o. I'm thinking it's like input output, but I don't know.
That would be my assumption on it.
What did you think of the documentation website?
The documentation website I felt like was very sparse.
Very sparse, yes. I couldn't find some things.
Yeah.
I mean, and sometimes it would mention it, but it wouldn't tell you much more about how to use it.
And Googling did not always give fruitful results because programming and I/O and language, it's pretty painful, especially with the proliferation of .io domains as well.
Right. Yeah. Well, and and I don't think there's much out there about it. So the few things I found were people's solutions to the problems in this book.
Yep. That was my primary source of things. Is I'm checking out this book, 7 languages in 7 weeks.
Yeah.
And I mean, I guess it was a plus because it was highly relevant to
almost too relevant.
Content.
I mean, I couldn't get help without cheating on these specific problems.
Yeah. Yeah.
Okay. Another thing I really loved was the interview with Steve DeCorte, the creator.
That's what I go
with. I didn't find the interview with the creator of Ruby to be that insightful, but this one was really cool. First off, he wrote it because his friend created a language called Cel, CEL, and was just asking for feedback on it. And he didn't know programming languages well enough to give him any feedback. So he went and started writing his own language.
Yeah.
Like, what? That's amazing.
I mean, that is sometimes what drives people, though, is their small projects can definitely pick up steam. I mean, some more than others. Like if you did you ever work in the days of CoffeeScript?
I worked in those days, not with CoffeeScript. There was one project.
Okay.
That it wasn't my choice, but it was in CoffeeScript.
That itself started as kind of a personal side project of Jeremy Ashkenash, I think it is, where he wanted to go and just kind of make his own programming language to scratch his own itch. Like there wasn't huge aspirations behind it. It was like I just want to see things this way, or I want to make JavaScript better and it should look like this. So I give Steve props as well for going and diving in and doing that, because I don't know, like creating a language that's actually fleshed out is pretty daunting, at least in my perspective.
I'm very impressed. The other thing that was interesting is he talks about why he doesn't have any syntactic sugar. He said it leads to extra parsing rules. And when you have extra parsing rules, then you have to keep those parsing rules in your head. So like you as the human writing the code also have to be a parser in addition to the computer being the parser, because you have to know those rules in order to conform to them. And so the more complicated language, the more of a parser you have to hold in your head. And so he just wanted something very simple. And apparently you can learn the language in 15-30 minutes. I didn't go through and read the documentation, so I only know the few things that this book points out. But yeah, I can believe that you can learn it in 30 minutes.
Yeah, it doesn't have a lot of core concepts in the language itself, but because of that, I also like that answer that he gives within the book, saying that it's more like an open-ended game where people do things with it that the designers never thought of. And it actually makes me think of, there was an article written by a guy, Y the Lucky Stiff, I believe, or _Y was kind of his alias that he went by. He was pretty well known in the Ruby community in the mid 2000s, And he, in 2008, started toying with IO just because he liked to explore and
Okay.
spread happiness and joy. Kind of, I don't know how the Ruby community aimed to be. And he went and did the builder exercise that is in this book. So even even him back in 2008 was solving the same problems that this book kind of brings up, where uh, they asked to make a builder that you write in a IO type syntax, but it produces an XML output, and talking about the power of messages being like these lazily evaluated things that they can be a structure that you can go and traverse at runtime, and how he loved that. And so it definitely goes back to Steve's perspective that it's like an open-ended game where people can go and find the extensibility in the language and come up with unique ways of using it.
And those are, like we talked about in the Ruby chapter, DSLs, domain specific languages. And I feel like I didn't really understand that at all until now, until these two chapters. But it helps me understand things like, how could JSX be a thing where you can have HTML inside of your JavaScript, but that actually compiles to JavaScript function calls.
Just going and taking kind of one tree and then interpreting it or transforming it into another shape. And IO specifically allows you to go and do things like extending its parser. That was one thing that I guess they had you do, or they demonstrated, was the notion of phone numbers. I think this was in day 2.
Yeah, this is in day 2. Let's go ahead and go to day 2 because I don't have much more in day 1.
Okay, that's fine. They gave the example of wanting to have phone numbers in a syntax that looked very much like a JSON object.
Yeah, it looks exactly like JSON, but it's not full JSON. It only supports a string on the left and a string on the right.
Yeah. And so I actually went and I can't say that it's truly full JSON, but I did go and add support for both curly brackets and square brackets. And you can go and nest those things inside of each other. So, and it really wasn't bad to write at all. It was pretty short. It took a little bit of getting used to how to take a message that was being received and dispatching it to something else. So I had the notion of like this JSON, which was just an object that had methods defined for both square brackets and curly brackets. And square brackets gets invoked if you pass square brackets to something, or pass it a message that starts and ends with square brackets. Then
so this tripped me up for a while when trying to do one of the problems.
Yeah,
if you don't say what square brackets mean, then you get this weird error message saying object doesn't respond to message square brackets, and square brackets is like spelled out. And so but then it's useful because then okay, I just need to write this method called square brackets, and then it'll know what the square bracket symbols mean.
It took me just a little bit to go and get that straight too, because I don't know if that was documented very well on the IO site.
I did not see that documented,
but it just behaved that way. And so using the error message and getting used to, oh, well, this isn't implemented, I obviously need to go and implement it. But what would happen when you did either curly brackets or square brackets is that those messages would have arguments. So for like each line or each comma separated thing within them would be an argument, but each one of those would be a message of its own.
Okay, yeah.
And so in both cases, what I wound up doing was looping over or for eaching over all of the arguments of the square bracket or curly bracket messages, and then dispatching those to my JSON object. And I mean, I'll share the code with you, but you can just call JSON and then give it JSON syntax, and it will go and populate nested objects. And I mean, I tested out doing arrays a few levels deep, and it works fine. So it was pretty cool to be able to write that out and say, I don't want to write IO syntax where I have to put colon equals, but instead I can use this other form, and it works.
Pretty cool.
Yeah. One thing I did learn with it though is there is the operator table. Did you catch that?
Yeah. So I mean, if you just go into the REPL and type out operator table, it will show you all of the operators and their precedence. So it'll be like 1 through 11, and next to each number is all the operators with that precedence. And then like those are your normal operators at the top, and then your assignment operators down below. And there's 3 different assignment operators, which is unusual for me.
Yeah.
But then it also prints out how to add things to either the operators or the assignment operators.
Yeah, by calling operator table and sending either add operator or add assign operator.
Yeah.
And that works out in the REPL, I believe. But if you are doing modifications to the operator table in a file, a problem arises in that something like the tokenizer or the parser of IO is run over the whole file before the operator table receives the message. And so you can't go and extend the syntax in the same file that you're using that extended syntax.
I saw something online about doing it in a separate file.
Yeah, that was something I kind of stumbled across and got kind of frustrated with. I think that was one of the things that took me longest was, why does this not work? And more importantly, why does it not work for me? But in the book, they had the example of extending the operator table in one file, and I said, why is it not doing that? And
I think I must have not run that example myself.
Yeah, maybe I didn't run that example because I didn't actually go and take it out of there. I mean, I made it sort of similar to it, but yeah, I don't actually. Now I look at it, I'm not quite sure. I know some people said that using doString would be all right because that would like start up the tokenizing and parsing again at like reading the string, and so you were able to do it at that point. But I really didn't want to go and inline a string or something. So instead, I just made kind of a startup file that went and added a operator for the colon, and then had that send the message of colon instead.
Okay.
And that got the job done for me, but that was definitely a place that I fumbled.
Anything else in day 2?
I don't know. There were a bunch of exercises. Oh yeah, there was Fibonacci. That was in day 2.
There was Fibonacci.
Yeah.
That was fun. So I did it with both looping and recursion. I did it in recursion first, and then it took me a little longer to figure out how to do it with looping, because it's just, you have to write more code to do it with a loop.
Kind of holding on to each of those values that is implied by calling the nested recursion. Yep. I did both as well, just because I wanted to see what the experience was like. And one thing I noticed was that doing the recursion was really slow.
No, I didn't really test it. I only did up to like 11, the 11th number.
So I got up to the point where I stopped enjoying waiting.
When did you enjoy waiting?
When did I enjoy waiting? Well, I mean, when you're doing number 10 like that, it wasn't too big of a deal. Like it was fast enough that like, human perception was pretty instant, so didn't bother me that much. But doing Fibonacci, the 30th Fibonacci on my 2015 MacBook took about 5.4 seconds.
Wow.
And yeah, which I did that one. And then as a comparison, I said, okay, well, I know that it makes a couple of points in the book that IO's performance is not top tier in all cases, or like because of its like extreme amount of flexibility. I get it. And so I went and checked it against doing it recursively in Ruby, and Fibonacci of 30 in Ruby took 150 milliseconds.
Mm-hmm.
So dramatically faster.
Did you see how far you'd have to go up in Ruby to make it take 5.4 seconds?
I couldn't, because at some point in Ruby, if you are doing floating point, it just hits infinity.
Oh, so pretty high then.
So yeah, like it goes all the way up to infinity, and then it just is stuck at infinity. So it's just
okay,
blazingly fast at any size. I mean, if you keep it as numbers and not that, then it does get slow. And I didn't measure that quite out. And with one thing that is redeeming for IO though is that its VM spins up faster than Ruby's. So using the loop form in IO to do Fibonacci of 30, it only took 47 milliseconds.
Okay.
Like including the startup time of IO. And comparing that to Ruby's loop form, including the startup of Ruby, it took 80 milliseconds. So the IO VM seems to start up faster than Ruby, and Ruby, however, seems to have faster function or method calls and recursion, at least in this particular instance. I mean, I wouldn't put lots of weight behind my not so scientific benchmarks, but in playing around with it, that is what I found, is that it is expensive to do deeper recursion in IO.
Oh, the one about changing the slash operator, the division operator to return 0 if the denominator is 0, that one was pretty fun, because you have to go in and change an operator. And it's also interesting because you need to hang on to the original division operator, because if the denominator is not 0, you still want to be able to divide.
Yeah.
So I had some trouble with that one originally, because if I tried to, well, first I just got into an infinite loop because I was calling divide from within the divide function.
Oh yeah.
And then I don't know what else I did, but I did something else where I was trying to copy divide into some other name, like spell out the word divide, right, and get a copy of it and save it there. But it didn't. Something I was doing didn't work. I eventually figured out you could do the get slot thing you were talking about earlier. So number get slot, pass in the slash, and then I've got a copy of it.
That's just what I did. Is I created numbered. I made a new slot of number div, and then used that when I actually needed to divide.
Yeah, I did it. I made a new slot called number divide, because normally, what does it return? Infinity?
Yep.
Yeah.
Yeah, because that's what it winds up being. So with floating points instead of yelling at you, which is nice.
And then in day 2, probably the hardest thing was making a prototype for a 2-dimensional list. And you've got getters and setters for getting and setting values at a certain X and Y. And you also initialize it at a certain size. And then you write a transpose method so that it flips all the X's and Y's. And I had trouble with that one, where I was trying to return a new copy, like a new, I don't know, what did you call this object? This 2-dimensional list?
I called it matrix.
I should have called it matrix. So we'll go with that. So I was trying to return a new matrix and copy things from the old matrix to the new matrix, just flipped. But then it was coming out really weird. It was coming out like A, B, B, F, C. It was just had a bunch of repeated letters in there. And turns out it was because it was modifying the original as it was copying it. and then it was copying weird because
Wow.
I had the matrix like A B C D E F G H I, and then I was trying to transpose it.
Yeah, interesting. I actually didn't do that bonus question because I was fighting with the whole JSON syntax, so I didn't do transpose. I did the matrix, but
yeah,
so good on you for doing it.
The only thing that I did that eventually made it work was instead of cloning, instead of saying matrix is a new object clone and then adding slots to it later, I actually had to do object clone and then send the message do, and then inside of do you can initialize all the slots. Something about that made it understand what self was. So like self is a reference to itself. Like in JavaScript, it would be the word this. Yep. So something about that made it work, and it wasn't like modifying the original. It was only modifying the new one that I was trying to return.
Yeah. So I mean that is what do
does.
It's,
that's how it do.
Yeah, and it was a common pattern that I even saw when like looking at some either IO examples or looking in, because I looked a little bit in their code base to try and figure out some things that I needed to debug, and they had the pattern of object clone, like they would do object clone and then they would pass the message do to that and then go from there, and then inside of that do everything is within that context of the object that was just cloned. So if you go and like create a new slot, then it is doing it on that cloned object, not a top level object.
And then the other bonus for this one was write a to file and from file method that just saves the matrix to a file and gets it from a file. I did it this really complicated way with a double, like a nested for loop, and just printing it out in some format with commas and new lines. Turns out it's a one-liner. There's a couple of methods for serializing and deserializing. And so I cheated and found out those existed, but then I went ahead and did it as if I didn't know those existed.
I mean, there's nothing wrong with using what's there, but also nothing wrong with going and figuring out a different way of doing it. Makes you appreciate what serializers do for you, right?
It wasn't too hard. It's just a lot more code. Okay, what do you think of day 3?
Yeah. So day 3, I guess day 3 was actually the one with the phone numbers, wasn't it? With the domain specific languages. So forward is kind of what you said in those list of bullet points really early on, where when you send a message, it will do things like checking if a slot exists on the object and either invoke that method or return the value that's in that slot. But if it's not there and it doesn't find it, then it will go and forward onto the object's prototype. But forwarding onto the object's prototype happens to be a slot that exists on the object prototype itself that says self.proto and passes it the message. And so you, as an object creator, or after having cloned an object, you can actually go and reassign forward to be something else. And then any message that winds up coming in, it gives you a hook to do as you please with it. So if you wanted to go and implement the Roman numeral example, you could go and do that. You could say Roman and then send it a message of I or II, and it could understand that and give back a result.
Yeah. And they do the example, of course, of converting some IO syntax into XML here.
Yeah.
And then it talks about how IO handles concurrency, which apparently does really well. And there's 3 main ways of doing it, or 3 main components: coroutines, actors, and futures. I feel like I didn't understand what a coroutine is.
So a coroutine is a way of for I guess running code to say, like, I'm giving up control so somebody else can take over.
So it looks like it has the yield message that you can have inside of your
Yes.
method. Is this kind of like JavaScript generators?
Yeah, similar to that. Where like the context is held. Like if you, like for example, when IO is running, that yield says, "All right, I'm done doing what I need to do. Anybody else that wants to do stuff can do their thing, and then come back to me." And like all of the locals and stuff that you've assigned, that like if you made like a local variable or a local slot within that method, then you would be able to access that once again even after the yield. So like that, all of that local state would get saved, even though it would start running something else for a little bit. It would come back to it in that same context.
Yeah. I said it's really good for specific times when you know it's you want to relinquish control. Like if and you're doing it explicitly instead of the language or the runtime trying to figure out when to do it for you.
Mm-hmm.
And a good time might be you're waiting for something from the server.
Yeah, saying I'm done now. Anybody else can do work if they would like.
Well, I'm not done. I'm not done, but I'm going to be waiting for a little bit. So
right, I'm done using the CPU, or at least I'm. This is a good stopping point for me for a little bit.
Good stopping point. That's a good way to say it.
Yeah, that was one thing that was I don't know if they call it out specifically in here, but maybe they do. Yeah, so they mention that Java and C-based languages, when they use threads, it is often preemptive multitasking, which is different than I/O, where preemptive multitasking means you can get interrupted in between any instruction that you're working on, and some other thread can start doing its thing. And yeah, it's good. It's good and bad. Like, I mean, you're kind of relying on the operating system's scheduler to go and choose the right thing. And in IO though, it seems like even though it will start up separate threads, they will not go and interrupt each other, but instead they wait for things to agree when they're ready to hand off things, which has the benefit of you can reduce like contention over a like shared mutable state or something like that, and prevent like threading issues where it works sometimes, but under load it doesn't work anymore because you're swapping up threads in the middle of assignments and stuff. So
cool. And then there's actors, which was pretty interesting because apparently you can make any method an actor just by sending it an asynchronous message.
Yeah.
And you just, what is it? You prepend it with two @ signs.
It depends on what you want. So I guess for actors and futures, if you don't really care about the result, then you would prepend your message with two @ signs, which I believe desugars down to, it's like send async.
Oh, so there is some sugar.
Yes. Yeah, there in the language itself, the @ signs are defined as send async.
So a future, you send a message with one @ sign in front of it,
and right, and so a future is kind of like a promise.
Yeah,
where it is a value that
it immediately returns a value, and let's see.
And it immediately returns a value, but if you try and access it, one thing that's kind of different is it's not like a promise where you have to say then or send it a message of then, but instead
or yield, like
right.
In JavaScript,
you don't have
you can
to
just
await the thing.
Right, await. In JavaScript, you can await it, and then you'll get the value when it's ready.
Right. In IO, if you try and access it beforehand, it will wait at that point, or it
just
will
block execution.
Right. So
that's interesting. There's no way to say Or is there a way to say go do other stuff until this is ready? I mean, I guess you could yield, but it could still come back to it and it's not ready yet.
Yeah, but I mean, at that point, if you've yielded and then it's gone all the way through everything and it comes back to you, then it might be an okay time to block anyways, because you've given everything else an opportunity to
Well, I wonder
do its processing.
I wonder if yield, does it only yield one time, or can it yield multiple times if it sees you're blocked on the next line or something? Probably not. But that could maybe be a performance optimization for IO.
Well, there is a. Is it in here? If you look at I don't know, just coroutine, current coroutine pause, where you're saying like, is it don't come back to me?
Yeah, that's on.
I'd
It's
have
on
to go
page
and
70,
look that
but
up.
I'm not sure what current coroutine pause does.
I guess it's like, don't come back to me, but also don't shut down
It
this
says
process or something.
It says it waits until all async messages complete and then exits.
Oh, there you go.
Either way, I didn't use any of this concurrency for the examples.
I didn't spend time on the examples, and I did the concurrency, so
okay,
at least a little bit. So
you didn't do the examples for day 3?
I didn't. I saw some of them get built out, but I didn't spend time digging in on trying to make the builder do that. Instead, I saw the notion that everything is an actor, and so I wanted to go and toy with that. So I made a I don't know, like a CLI basic thing where you would go and it would sit in a loop requesting or asking for lines of text from standard input that you could type in, and then when you did that, it would go and asynchronously take whatever line that you sent to some other actor object, which would then go and do some work, which my work was just waiting, but it could be actually hitting some endpoint. Like I had it ask the question of like, give me a movie name. So in reality, it could go and hit something like IMDb or something. But either way, I had it go do that. And then eventually when that thing came back, it would go and that actor that had done the lookup would tell my original actor, I called it the UI actor, that it was ready or that it had a response. And so at the point that I had yielded again, so like after sending another message, then it would go and print like, I got this result.
Okay.
So give me a chance to do like the back and forth thing. But I did find that when I did that, or I guess specifically when using the send async, that the sender of the call would get lost or not included on the message that was sent asynchronously. It was kind of a surprising behavior.
That's probably what I was talking about earlier, where I had to wrap it in a do.
I don't know, because like if I didn't do it asynchronously, it worked fine because it wasn't related to self. But I think it's the fact that send async is a method on the prototype of that object, and that is what passes the message along. That just the original sender just doesn't get included with it. And so what I wound up having to do is actually say I sent self along with that message to say, hey, call me when you're ready, and that worked.
Interesting.
Yeah.
I don't know if if IMDb has an API, but you might have to use. Does it? I think I looked into it before. And I don't think it does, but there's like the movie data DB.
Okay. Well, I would have to maybe try it out with that then.
I don't know. Did you look into how to make an HTTP request?
So in the book, it actually brings up using URL. I think it's in the book. Maybe it was a blog post or something. But there's a URL object, and they sent it fetch. Oh yeah, they do it in the book. So under futures, where it does future result URL with something. So when building IO through Brew, URL is not included in there. And so I didn't have a way of making HTTP request. Otherwise, I would have gone that stretch.
I had a similar problem where my version of IO didn't have random. One of the problems was have it generate a random number and then try to guess it. So then I had to use the XKCD version of random number generator, which is the number 4.
Oh, I thought you were going to read from dev random.
Oh, I didn't think about that. What is that again?
Something you could try out. So it's like a fake file on your file system that will it will give you back random bytes, and so you can ask for however many random bytes that you want.
Change?
So it is not an actual file. So every time every byte that's read off of it will be a new random one. So you can read from it all you want and get random bytes.
I should have done that. Yeah.
Well,
I can go update my code. I know how to read files and write files. All right. You have anything in conclusion?
In conclusion, I enjoyed it as an experience. At first I was kind of on the fence of what makes this so special. Like, I mean, especially like I said, having done Lua, like I was looking at it from that, and I said, this isn't dramatically different. I think what really made it stand out was starting to see like the concurrency type of stuff. And I know Lua does have coroutines as well, but like the fact that there are some battery included things that I didn't expect in IO that are there, like having a thread model. Like that's not something that every language has, and having a built-in concurrency model, I mean, definitely shapes the possibilities of a language, and shapes and can potentially help or hurt depending on what language it is. Because I mean, even looking at something like Ruby, where it has threads and you can use threads, but Ruby also has a global interpreter lock where like while you can't actually have more than one thing happening at once against the Ruby interpreter. So IO can be like IO, not the language, but like operations, like those can be on a thread and happening outside, and they're fine. But either way, given that like asynchronous stuff is so baked into IO because of the futures and actor type behavior, it definitely makes it well suited for some of that. So I was surprised by that, and I liked it. And I don't know if I would ever use it for anything production wise, given the state of its community. And I mean, its last stable release was in 2017, and I mean it's moving along, but I don't know what project I would go and take the risk.
Yeah, I mean, it does say that one of its one good thing about it is that it's so small, so you can use it in embedded systems and places where space is a consideration.
Makes sense. Yeah, it definitely seems like it would be kind of a decent fit for a more embedded case where it was a small.
Yeah, I liked it as well. It really kind of bent my mind and made me think in different ways. It's such a different, simple syntax. One thing that threw me off was the different assignment operators. There's 3 different ones. I only use 2 of them, but you have to do : equals if you're assigning to a slot for the first time. And I'm not sure what the benefit of that is. Do you have any thoughts on why that is?
I don't know, other than for like sake of, I don't know if it's like simplicity of implementation or what, because then you don't have to check for the existence of something. I did figure out why there are the 3 different kinds, like why there is the colon
equals creates a getter.
Equals.
Is that right? Okay.
Right. A getter and a setter. I guess it is the setter that is
it creates the
kind of
setter,
key thing. So it will add a slot, but then you can also pass a message that is set the name of that slot.
So yeah, I didn't use that one.
I think that I did once on my Matrix or something. I don't know. I'd have to go and see, but probably didn't even.
So yeah, it was easier than expected to write some of these programs, but then other ones were quite a challenge. And with the lack of documentation, I never would have been able to write them, except that other people have done these problems before and posted their solutions online. So I would love to see it grow, and I'd love to see where it goes. And like you said, I wouldn't use it in production. I'm glad that other people are, a few people. Yeah,
putting it on satellites, right? Yeah, that's
let's see. There was another example of where it's being used. I thought was cool in the interview. Oh, he said Pixar uses it, but with a company as big as Pixar, it could be used for anything by some small team. Just saying Pixar uses it sounds really impressive, but who knows?
That is true. Yeah. But people are using it.
I feel like this book has given it a lot of exposure.
Yeah, there's definitely a benefit to getting featured in a book. But I enjoyed it, and it was not completely mind-bending, but definitely like enlightening, and I enjoyed my time with IO, and I am also looking forward to Prologue ahead because I've heard about Prologue and spent zero time in it, and so I feel like this one is going to flip my world upside down.
Yeah, did you see what character Prologue is?
I did not even look at that yet.
It is Raymond from Rain Man, the main character on Rain Man.
Okay. Yes.
Yep.
Then my world is about to get flipped upside down. So
yeah, looking forward to it.
Maybe different next week.
So you can follow the show on Twitter at BookBitesFM. You can follow each of us. I'm at Agarhar, and Jason is at Staten Jason. If you haven't already, leave us a review, and we'd love to hear from you. See you next time.
Later.
All right.